Hey guys, welcome to College Algebra. I hope you are as excited as I am. I know we are going to have a great time learning math. It's definitely going to be a crazy 8 weeks, but together we can get through it. I have made a blank shell of notes for you guys to fill in to make this a little bit easier. So if you haven't printed those, you might want to go ahead and do that and make sure that you do that weekly. But let's get started. So we're going to be seeing whether or not things are functions. So let's start with some definitions. The first one is telling us that a relation is a set of ordered pairs. Now, inside the set of ordered pairs, I want to talk about the first component. That first component is going to be called the domain. However, it's also called some extra stuff. That individual element is also known as an input value or an independent variable. The second one is called the range. And then an individual element is going to be known as the output value or the dependent variable. And then if you look right here, I have given you some more things, mainly the X and the Y, and just kind of made a quick little outline so that you can try to remember that anytime we say domain, input, independent, we're talking about the X, range, output, and dependent, we are talking about the Y. Okay, a relation that assigns a single element in the range to each element in the domain is called a function. With a function, there is only ever one output for any input. So an easy way to remember that, because we can only have one output for any input, is basically that the X's can't repeat. Okay, so that's very important. So let's come down here to these examples. So we are going to determine whether or not the relation represents a function and then find the domain and range of those which ones are functions. So the first thing you mainly want to do is look at all those X's. So if I look here, remember X's are the ones that are in the front. Okay, so did any of those repeat? And no, they did not. So we are going to say that this one is a function. Now remember, it wants us to tell us the domain and range. So we're going to get set up for our domain, and then we're going to set up for our range. But I do want to take a quick second here to make a little note that when you are doing this, you got to make sure that you order them from least to greatest. Okay, so if we look at all the ones that I highlighted, because those are our domains, if you look at it actually from left to right, it's already written in from least to greatest. So I want to use a squiggly bracket. Do not use a parenthesis or a bracket, because those mean something else, and then I am going to list those. Okay, now if we look at the range, which are the ones I did not highlight, we have a 1, a 0, a 1, a 0, and a 1. So those are our K. So that means we only have a 0 and a 1. So again, I'm going to make an extra note here saying don't repeat. So when you write these, do not repeat them. Okay, let's go look at the next example. So input X are all of these right there. So as we can see, again, this one is a function. So the domain, it's actually in order from least to greatest. So I'm just going to go ahead and rewrite that. And then let's look at the range. So -4, -2, 0, 2, and 4. None of those repeat, and they're actually already in order for us. And there we go. Okay, let's look at C. So again, I'm going to grab my highlighter. Here's our domain. Okay, so I want you to think about this when you're looking at this. This one's actually called a mapping. So when you look at a mapping, it kind of tells you where they go to. So like -2 is going to the 3. And then when you look at that -1 is going to 3, but -1 is also going to a 4. So that right there cannot happen. So therefore, this one is not a function. Okay, and then let's look at the last one. So to look at this one, since we're given a graph, I want to go look at every single one of my dots. So this dot goes to the -2. That dot's on the -1. That one goes to 0. That one's on 1. And that one goes to 2. So therefore, my x's are not repeating. So therefore, this is a function. So the domain is all those ones that I looked at. So if I do it from left to right, I can put them in order. -2, -1, 0, 1, and 2. So now let's go look at the range. Okay, so I'm going to actually switch colors on this one. Okay, and if you do it from bottom up, then they'll be in order from least to greatest. So this y value right here is at a -1. This y value is at 0. This y value is at a 3. And remember, we do not write any repeats. Okay. The next thing is you could use a vertical line test. So the vertical line test is basically you draw a... Okay, so like for instance, if I go back to D, let me switch to a different color. So this vertical line test, what I could have done on D was I could have just drew a vertical line. And if you notice, every single dot went through the line once. So that also means it's a function. However, there's this thing called a horizontal line test. If you do a horizontal line test and it only touches a point once, then that means its inverse is not a function, but we'll get there later on. But if I can do a vertical line test and a horizontal line test and it passes, then it means that the function, the graph, or whatever we're looking at is a one-to-one function. So we'll talk about that in just a second. So these next ones are determine whether or not the relation as an equation or a graph will be a function. So there's a couple different things that I would like to talk about here in case you have forgotten. One, see if you can solve the equation for y. So for instance, on A, to get y by itself, I would have to subtract this over. So y would equal a -x² + 1. Okay, so this is where I would like for you just to make a few little notes. Okay, this x² right here is what allows us to know that this is a quadratic function. We'll learn more about these later. And also, if you printed that functions paper that I had posted in Blackboard, it has a quick overview of different type of functions that we'll be learning this semester. Okay, a quadratic makes a U. Okay, now we'll learn more about this later, but that negative in the front is actually going to make that flip and go this way. So if I was to draw, and I'll go ahead and switch back to that pink, a vertical line through any part of this graph, particularly this bottom one, okay, I would only touch it once. So therefore, this one would be a function. A quadratic will be a function. Okay, now here's a crazy thing if we look at b. Okay, if I try to start solving for y, we're going to have to do some extra stuff here. So let's go ahead and add that x to the other side. So I'm going to get x plus 1. That looks like a y. There we go. And then to undo a square, we have to square root both sides. Okay. And because we don't know if it's positive or negative, we have to do plus or minus. And then x plus 1. And what I mean by that is, let's say, I'll just do it on the side. Square root of 9 is a 3. That is correct. However, 3 squared equals 9. And so does a negative 3 squared equals a 9. They both equal at 9. So therefore, we have to have a plus or minus. So it's kind of the same situation that we're doing right here. Because when we're solving, we don't know if it was the positive version or the negative version. Okay, so when this situation happens, okay, this is a square root function. Okay, so when you have a positive and a negative, so when we go to graph this, you will have one going this way, that's the positive, but you're also going to have one going this way. So if I was to do the vertical line test on this one, it would fail it because it touches it twice. So therefore, this one is not a function. Okay. C, we could actually do some solving, but we don't need to because this one, based off of its form, already tells us what it is. This right here means a circle. Okay. So therefore, if I was to draw a circle, and then I drew that vertical line test, it would fail it. So therefore, this one is not a function. Okay, so now let's go look at some graphs on the next page. So if I was to draw a vertical line, this one would be not a function because it crosses it twice. Okay, so let's think. I could draw one here, 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 here. Doesn't matter where I draw this. This one will be a function. Okay, so let's look at this one. I could draw it here, 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 and only cross it once. So therefore, this one is a function. Okay, so now we're going to put that horizontal line test to practice. Okay, so remember, it is going to be 1-to-1 if the x's don't repeat and the y's do not repeat. Okay, so I'm going to bring that down a little bit more. There we go. So here we go. Switch to highlighter real quick. So here's the x's. Did any of them repeat? Okay, and then look here. Did any of those repeat? And the answer should have been no for the x's and yes for the y's. So therefore, this one is not 1-to-1. So let's do that again. So let's look at the x's first. Here, 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 and here. Okay, did those repeat? Now let's go look at the y's. Here, 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 here. So the answer should have been to both of them that they did not repeat. So this one is 1-to-1. So what I like about the next one is the graphs to me are just so much easier. So let's think about it. If I draw a line like this anywhere on that graph, it would pass the vertical line test. I'm going to go ahead and do B too. If I draw a line anywhere on here, would it pass the vertical line test? Yes. Same thing on this one. If I drew it anywhere, it would pass it. Okay, so all these are functions. That's what it says in the question, but I just wanted to, again, just to show you guys. Okay, now we're going to do the horizontal line test. Passes, fails. It could pass here, but it fails here. So this one trumps it all. Okay, so therefore, we have yes, this one is 1 to 1. This one is no for 1 to 1. And this one is no for 1 to 1. Okay. Okay, next part of your notes is basically talking about what does f of x mean, okay? So basically what happens when we're dealing with, oops, it went too far. When we're dealing with functions, okay, we mainly represent it by f of x, okay? And that is what it reads. Or you can say f at x, but most of the time, even when I'm reading it, you will hear it as f of x. Now, one biggest thing is to make this note of, okay? It does not mean f times x. It means f of x. What I basically tell my students is that this is a fancy term for y. And basically, the way I just call it fancy is because of this thing right here, which is a great example. Okay, so notice we have two equations. Okay, I wrote the equation y equals f of x plus 2, and then I changed it to f of x equals 5x plus 2. Because remember, y and f of x, these are the same thing. Okay, f of x is just fancy for y, and this is the reason why. Okay, if I was to ask you, and I'm going to kind of forget about that example there. I'm just going to go ahead and write one. Let's just make it easy. I'm going to tell you that x equals 1. Okay, so that means I would plug in a 1 right here. So f times 1 plus 2. F times 1 is 5. 5 plus 2 equals 7. Okay, that's fine and dandy, okay? But what f of x does is I can write it as f of 1 equals 7. And so what ends up happening is I know that for this function, I plugged in a 1 and got a 7. So like for instance over here, if I erase all that work and I just said y is 7, I don't know what I plugged in to get that 7. I don't know. But what I do know when it's in function notation is that I plugged in a 1 and I got a 7 out of it. So it gives us more information when solving these problems. So we're going to go practice function notation and plugging in just like I did. Okay, so here is some of the examples that we're going to do. So notice up here, I gave you 4 different functions. So we have the f function, the g function, the h function, and the k function. So each example that we're going to do, we have to make sure we match it with the right function. So notice on A, I gave you the f function. So it's asking me to find f of 4. So all I want to do is plug in 4. So remember when you plug in, it's very important if you use those parentheses. So every spot I see an X, I am going to plug that in. So that's going to go there and here. Okay. So 4 squared is 16. 7 times 4 is 28. And then we're going to drop that minus 8. Now make sure you do your math left to right. And when 16 plus 28 minus 8 is going to give us a 36. Okay, so we're not solving equations here. We are just substituting in and simplifying down. Now, if you want to write your answer as f of 4 equals 36, that is fine. However, I just don't want you solving the equation because the answer to this problem is 36. Okay, so B is asking us to go to the G function. So that means I got to take this -1 and plug it in right here. Square root of a -1, and then plus 2 on the outside. Okay, now I don't know what you remember, but this right here is not real. Square root of a -1 is imaginary, and that is an I. So we would have I plus 2, or you can put it in the correct form, 2 plus I. We will learn more about those later if you have forgotten them. Okay. C is asking for the H function. So that means wherever an X is, I got to plug in a 2t. So right there's our X. We do 2t cubed minus 3. Now, depending on what you have learned, we can distribute that power. However, sometimes that can cause mistakes later on. So on this one, what I would like to do is I just want to come up here for a second. 2t cubed means 2t times 2t times 2t. So 2 times 2 is, times 2 is, and hopefully you said 8. T times t times t. When you multiply, you add power. So 1 plus 1 plus 1 would give us a 3. And then you just drop your minus 3. Those are not like terms, so therefore we are done. Okay, next one is the K function. Now this is telling me this time that I have to plug into the X spot, K or X plus 2. So in the K function, all of this is going right there. So we're going to have 7x plus 2 minus 8. So that will be 7x plus 14 minus 8. Put your two like terms together. So 7x plus 6. Okay. Let's go to the next one is the G function. So I'm going back to that one. So I'm going to switch colors for the ones that I end up repeating. So we're going to take this and plug it in right there. So square root of x squared plus 2. Okay, a square root and a square are inverses of each other, so they cancel. And my computer always takes it away, so I try not to scribble too much. So all of that goes away. So you're left with just x plus 2. Okay. Oh, the next one. Let's skip F for now. Let me go ahead and go and do K real quick. So this one is completely different. So F and G that we're getting ready to do examples are completely different. So I'm going to skip to G real quick. Notice that it says K of X is negative 22. So what this problem is doing here is it wants you to replace the K of X with a negative 22. So you're actually going to kind of cross that out and make that a negative 22. So negative 22 equals 7x minus 8. So therefore, you are just going to solve this equation. So we're going to add 8 to both sides. So negative 22 plus 8 is a negative 14. And then we're going to divide by 7 on both sides. So x equals a negative 2. Okay, so this one basically you are figuring out the input that gave us an output of a negative 22. Okay, let's go back and do f. The reason why I wanted to skip this one is because we're going to have to look at two separate functions. So I'm actually going to highlight this right here because that's the part of the problem that I'm going to do in pink. Okay, so this is telling me to take that -3 and I'm going to plug it in here and in here. So -3 squared plus 7 times -3 minus 8. So we're just going to work with this part of the problem. So -3 squared is 9. 7 times a -3 is a -21, and then minus 8. So 9 minus 21 and minus 8 gives us a -20. That is our answer for that. Now, I'm actually going to highlight this negative with blue just so that you can see me drop it. Then the next part of the problem, I am actually going to do with green. Okay, so this problem here is telling us to get the g function and plug in a 16. So I'm going to go square root of 16 plus 2. But notice this 2 right here. Okay, that is wanting me to multiply whatever I get as my answer. So the square root of 16 is a 4. 4 plus 2 is a 6. And I'm going to go ahead and just put that right there. And then 2 minus 6, or 2 times 6, is a 12. So the question is wanting us to do -20 minus 12. And that will equal a -32. So I try to keep things a little color coordinated there for you to help you make sure you're understanding that. Okay, so the next thing is can you do that on a graph? And I actually kind of really like these. So if I scroll down here, okay, probably kind of do the same thing with the color coordinating. Okay, we'll start off with green. So this one we want to evaluate the f function at 1. So you're just going to look at the 1 and go up. And what do you think that is? Well, we just go like that. So the answer is 2. Okay. And of course, if there's any time you guys want to pause this video, so if you want to practice them on your own, you are more than welcome to. We're going to do this one in pink. So now it's wanting me to look at a -3. So it looks like that one might be a half. Okay, now notice the next one, it switches. Okay, so this time it's saying that f of x is a 4. So we're actually having to figure out the x value for it. So here's the 4. Well, what would be the x value that would give that to you? Well, come down here to the x-axis. It means 0 gave it to us. Okay. Let's see what else, what other color I can get. We can try purple. Okay. Now this one is saying 1. So let's look. Here's 1. Well, let's see. Could it be a 2? Yeah, looks like it's a 2. Let's check over here too. And it also looks like a -2. Okay. So you just have to work backwards if you're given the actual f of x value. If not, then you look at the x and find the y. But if you're given the f of x, which is the y, you got to find your x. Okay. So now let's look at a table. Okay. So let's go do finding function values from a table. Okay. So let's look here. So would the relation be a function? So look at the x's. Do any of the x's repeat? So therefore, it is a function. Would it be 1 to 1? So now check your f of x values / your y values. Do any of those repeat? Nope. So therefore, you are correct. It is 1 to 1. Find basically the y value when x is 5. So you should be looking right here. So if you told me 68, you are correct. Now, f of x is 7, so look at your f of x line and tell me what you get. So that is right here, so the answer is 8. Because remember, this right here is a y value. This right here is an x value. Okay, and of course, / f of x. Okay, the last thing we're going to cover for today is the difference of quotients formula. So you're going to be given some type of problem, and you're going to be asked to use the difference quotient formula to simplify it. Okay, so basically it is a lot of plugging in like we just did. So I'm also going to color coordinate this one. So let's start with pink. So we're going to do this portion of the problem in pink. So that means every single spot that I see an x, I have to put x plus h. So we're going to go 2x plus h squared minus 3x plus h plus 1. Okay. And then I'm going to use my blue as the problem. And then I am going to use my green for the f of x. Okay, so f of x is just going to be the original problem. I'm going to put this one in brackets. Okay, and then I'm going to use my blue to go back to my original problem because, like I said, I want to try to keep everything color coordinated for you. Okay, so that x plus h squared, okay, that is not something that I've completely reviewed yet. So we do have a power, which means we have to write it twice. So I'm going to come over here and I'm going to write it twice. So I do not know if you guys remember, but this is a problem that you will have to FOIL. So you're going to multiply your first, which is x times x, that's an x squared. Your outer, which is x times h, which would be xh. Your inner, which is h times x, which is another hx. And then your last, which is h times h, which is h squared. You have two of these in the middle, so an xh plus xh becomes a 2xh. And then I'm going to drop down my h squared and my x squared. Okay? So that means this will change to 2 times x squared plus 2xh plus h squared. And I'm actually just going to rewrite my problem right now, because I don't want to do too much at one time. I'm going to try to keep that color coordinated, so I'm going to change it to blue. Okay, so now we are going to go finish the pink part of the problem. Okay, so that means we have to go distribute. So 2 times x squared, 2x squared. 2 times 2xh is a 4xh. 2 times h squared is a 2h squared. Please be careful. This is a negative 3 times x. So negative 3x. Negative 3 times h, negative 3h, and then a plus 1. Now for this green portion, I am going to go ahead and distribute this negative to here, here, and to here. So a positive is now a negative. Negative is now a positive, and a positive is now a negative. And then the original part of the problem divided by h. So let's look and see what we got. 2x squared minus 2x squared cancel. Negative 3x and 3x cancels. 1 minus 1 cancels. So it looks like we have 4xh plus 2h squared minus 3h all over h. Now notice on this problem, okay, every term has an h in it. So we are going to reduce it by 1h. So that means we're going to be left with 4x because these cancel. You know what I think I want to do? I think I want to visually show you first. So I'm going to separate them. 4xh plus 2h squared over h minus 3h over h. Because I want you to visually see these cancel. So these h's cancel, which leaves us with 4x. There's 2 on top, so I'm going to cancel out that with that. See if I do it. There it goes. Plus 2h. And then the h's here cancel, so minus 3. So therefore, this will be your answer. Hope you guys enjoyed the lesson. See you next time.